Hello everyone, welcome to this video. In this video, we shall be starting with another topic, which is the external direct product. So what is this external direct product? So let's see the definition first of all. Suppose we have many groups and we wanted to club all such groups. So we have group G1, we have group G2, we have group G3, and we wanted to club all of them and we wanted to make them as one such group. So how we can do that? We in this case have to use the external direct product, right? So the definition here, how we can do that with, so this group G1 would have some relation, right? Some different group operation. Group G2 would have some different group operation. Third group would have some different group operation. So how we may combine all the elements together such that we may have a group in itself. So here the definition tell you that. So in order to understand this thing, let us first of all suppose n such groups. So let's call those groups as G1, G2 up to Gn. So they are in total n such groups. So this be the finite collection of groups. We have finite groups with us. Then what is the external direct product of all such groups? The external direct product of each of G1, G2 up to Gn is written as this thing. Now this is the notation. What we do, we in between each of the groups we insert the symbol, which is nothing but a plus sign surrounded by a circle, right? This is the symbol for direct product. So this is the notation. And how do we define this set? We define this set by considering all n tuples, because we are considering n groups, so therefore we would have n tuple, for which the ith component is an element of Gi, right? And the operation here is component wise. So how does this work at all? So symbolically this means that all the elements here in this set or in this group, they would be of this kind: G1, G2, G3, G4 up to Gn, where each of these G1, this G1 would be a member of capital G1 group. Small g2 would be a member of this capital G2 group. Small g3 would be a member of this small capital G3 group. Small gn would be a member of this capital Gn group, right? So each gi is a member of capital Gi group. And how do we apply the operation here? So in order to see that, we take one such tuple, we take another such tuple, and we multiply them together. So how do we multiply them? What we do, we take the first element here and multiply them together. Now here you see we are just taking the multiplication. However, here we would have star 1. So that means here we would have the operation which is defined for our first group. Then we have G2 dash. We take the second element from the first entry, second element from the second entry, and then we compose both of them in such a way that we are applying the group operation for second group, which is G2, right? And so we keep on doing like this. So each product here, so you should note this thing and keep this thing in your mind, that each product of such kind, Gi dash, that is performed by taking the group operation for the group capital Gi, right? And this is done for each of the group. Okay, one more thing, if each of the groups, each of the group that you are taking, G1, G2 up to Gn, if they are finite in nature, then the order of this external product could be reduced by to multiplying the orders of individual groups. So that means we multiply the orders of each of the groups together in order to obtain the order of this group. Why this is so? Because it is in accordance with the number of such elements, number of such tuples which are formed here. So obviously it is just the arrangement of these G1, G2, Gn in n places. So how many such combinations could be made is given by this particular order. So in fact, this construction of direct products, this has been studied by us in the previous classes. In linear algebra, you might have studied the algebra of such kind, and in physics, you might have dealt with vectors of such kind. In fact, you know, this plane, R2 plane, could be represented as the direct product of the real line with the real line, right? And in fact, this three-dimensional space is nothing but the external direct product of the real line with the real line with the real line, right? And here in each of the following cases, we have the group operation as component wise addition. So that means if we are in 3D space, if we have the first point as x1, y1, z1, right, and we have the second point as x2, y2 and z2, so when we compose them together, so it would just be x1 plus x2, then it would be y1 plus y2, and then it would be z1 plus z2. So this is how we apply the operation here. Here both x1, y1, z1, this is a member of R cube, and again x2, y2 and z2, this is a member of R cube, right? So I hope you understood the definition of this external direct product. In the next video, I shall be giving you more examples for this external direct product. Well, that is it for this video. Thank you for watching.